Welcome back to the Dr. Liu VCE Physics channel. In this video, we'll go through the 2018 VCE Physics exam, focusing on questions related to special relativity. My explanations may not be perfect, so if any teachers, parents, or students notice any errors, please feel free to offer your feedback. The Lorentz factor increases nonlinearly as an object's speed increases. For speeds much less than the speed of light, the factor is approximately unity. However, as the speed asymptotically approaches c, the Lorentz factor increases without limit. When the velocity of a particle, such as a proton, is non-relativistic, its classical and relativistic kinetic energies are virtually identical. Conversely, as the velocity approaches the ultimate cosmic speed limit, the relativistic kinetic energy increases unboundedly, clearly illustrating the inapplicability of the classical model at high speeds. Experimental uncertainty is an estimate of the precision and reliability of measured or derived quantities, quantified by a specific interval and confidence level that collectively define the range within which the true value lies after accounting for sources of error, such as random fluctuations and instrument limitations. With the scale's smallest division being 1 ampere, the uncertainty of the pointer reading is assigned a value of plus or minus 0.5 ampere, derived from the standard practice of using half the scale division as the instrument uncertainty. An inertial frame of reference is defined as one with zero acceleration, that is, moving at constant velocity, or at rest. Because velocity is a vector that requires both constant magnitude, speed, and constant direction, a spaceship merely traveling at constant speed, e.g., in a uniform circular orbit, is not guaranteed to be an inertial frame. Its changing direction implies acceleration and therefore a non-inertial frame. A stationary scientist in an inertial frame observes a spaceship moving at a constant velocity and notes that the normally operating clocks on the ship run 8 times slower than her own. Therefore, the time on the spaceship is dilated by a Lorentz factor a gamma of 8, meaning the kinetic energy of the spaceship in her frame is correctly given by the relativistic kinetic energy formula. Given a quasar receding from Earth at a speed of 0.704 c, resulting in a Lorentz factor gamma equals 1.41, the 20-hour time interval observed by scientists in the Earth frame constitutes the dilated time. The corresponding proper time, the time interval measured in the quasar's own frame of reference, is then calculated using this time dilation factor gamma. Section weighting, total marks, 11 marks contribution, 8.5% of total assessment multiple choice, 4 marks, Q13, Lorentz Factor Curve, identify the curve showing the relationship between speed and the Lorentz factor a gamma, Q14, kinetic energy, compare classical versus relativistic kinetic energy. Q18 and Q19, uncertainty, define and apply the concept of measurement uncertainty. Short answer, 7 marks, Q14, inertial frames, distinguish between constant velocity, inertial frame, and constant speed, non-inertial frame. Q16 and Q17, time dilation, identify gamma as the ratio of dilated time, t, to proper time, t0. Calculate proper time using the observed dilated time and the Lorentz factor. Should you require assistance, please feel free to connect via WeChat or WhatsApp and send an email. Thank you for your attention. Kindly note the details of Dr. Liu's VCE Physics, Chemistry, and Biology channels.